Okay, nice. Good morning, everybody. Today I will present to you the Canadian Coast Guard ship Icebreaker as a mobile scientific laboratory in the Canadian Arctic. My name is Tahiana Ratsimbazafy, and I work as a data coordinator at Amundsen Science. First, we will talk about Amundsen Science, and then the CCGS Amundsen, and then the data collected with that ship in the Canadian Arctic. And we will speak about open data, open science that we are moving to. Amundsen Science is a nonprofit corporation responsible for the management of the scientific mandate of the research icebreaker CCGS Amundsen. It is hosted at Université Laval, Quebec. Amundsen Science manages the vessel's pool of scientific equipment, coordinates the deployment of the icebreaker for science, and provide logistical, financial, and technical support to user program. It does support building knowledge through the sharing of scientific data. It was refitted, the CCGS was refitted as a research vessel in 2003 with the funds coming from the Canadian Foundation for Innovation. Amundsen Science support scientists to collect data in the Arctic aboard the vessel. And many students and scientists were accommodated on the ship to do their field work. There are many already scientific publications that are already published out there. They are openly accessible for the public with about 12 times the Earth circumference, the trajectory that have been done by the Amundsen. Many data sets have outputted from several scientific expeditions during these last 2 decades. In this slide, we have an overview of the kind of data set that are collected aboard the ship. They are mostly classified as depth-related profile data, that is the oceanographic data here. There is as well a sonar data acquired by multi-beam mostly that are used to map the seafloor along the track of the ship. We have as well an ROV, remote operated vehicle, equipped with 2 arms and a few cameras that are taking pictures and videos along its dive. And the 2 arms serves as to collect samples on the seabed, collecting sediment or some biological entities. There is as well a camera 360-degree view on the ship. We use mostly these images to produce another data set that might be very useful for scientists. We will see that in the next few slides. We have another data here about cable length these kind of data are mostly used by technicians on the ship to some technical things. There is as well atmospheric data. There are sensors in the ship that recording on its way the wind speed, wind direction, humidity, pressure, atmospheric pressure, air temperature. There is, of course, navigation data and scientific event log. In this part, we can have all the different type of activity that have been done for each station that have been visited by the ship. In this slide, we see a general workflow of the data since they're acquired aboard the ship to their final publication on the web portals. After being acquired on the ship, the data are stored at Université Laval. There, they are processed and QA/QC. Metadata are additional metadata are as well added to the data to document the data and reformat the data in order to meet the requirement and the state of the art of the data publication on the internet. A use case that we have working on during the last 2 or 3 years, I guess, in the project CCGS, Canadian Consortium for Arctic Data Interoperability. We have selected a data set from the CTD Rosette. The CTD Rosette acquired a water sample with its 24 bottle, 12 liter each, and scientists collect water in this. And then there is as well sensors that installed at the bottom of the CTD Rosette. So these electronic sensors record the full profile of the water column, and the water sample are taken by scientists and then analyzed in laboratory. There they come back to Amundsen Science and look for the bottle file in order to compare, combine these data with their results in order to have a full, a complete data set for to be ready for analysis. So to match these needs, we work on standardizing these bottle files, which are proprietary format, not very user-friendly to be read, not really friendly human for reading. So we transform them into a CSV or NetCDF. NetCDF, as we know that it's a very self-content format and best for server-to-server data. And the data are disseminated with open-dap-based server like Hyrax or ERDAP. We are using Hyrax server from the Polar Data Catalog and ERDAP at University of Manitoba. Talking about data formats and dissemination, the variable names of the variable name in the data, they are proprietary, and we picked the British Oceanographic Data Center standard to be applied to these variable names. We use Creative Commons attribution as a public license for the data. About the photo and video, we use JPEG, MP4, GeoTIFF for the map of the seabed, and OpenDAP as a dissemination service. Here is this an example of the photo 360 degree photo of the surrounding of the ship. We combined three scenes like this and project it into the vertical in order to have an overview of the surrounding of the ship. And we intend to produce a kind of sea ice coverage estimation with this kind of data, and they will be published and accessible for the public. And we, for each photo, where there are geolocation information, like latitude and longitude, so we can have a map of where each photo were taken, and we use a GeoPackage format for them. So this is an example of a view of where all photos were taken during the leg 2 of the expedition of 2021. The photo that I have showed you have been taken in the right red spot in here. Here is an example of the ROV taking samples at the sea floor, taking sediment and some other samples in here. The challenge of documenting this kind of data is the complexity of the trajectory of the ROV from the ship into the place where it collects the data in the bottom of the sea. So we use a dive number to differentiate each report, and continue to apply this in the name of the archive. After that, let's talk about the data paper that we are working during the last years. The data paper we're working on presents data collected during the 2021 expedition. It presents data from the CTD-OZ, MVP, thermosalinograph or TSG, and multibeam. The transect we are seeing in here is a transect of dissolved oxygen that have been collected in this transect in the North Water Polynia in here. The MVP, is an instrument like a fish, a big fish, over 2 meters, for example. It is dragged behind the ship and doing several dives while the ship is moving. And during each dive, the MVP records variables, so like salinity or temperature of the water, or dissolved oxygen during its free fall, and then recovering again. And what I want to say is the data from the MVP is very interesting in kind of spatial resolution, because within 1 kilometer, you can have like 2 or 3 dives of the MVP. So we have this very dense data that we see in here in the transect. Next one, the thermosalinograph data are collected in the sea surface. The TSG system is installed at about 7 meter beneath the water surface on the ship, and it measures salinity, the practical salinity, and the temperature on the surface. And we, in the data paper, we highlighted this gradient of salinity from the open sea into the inland water in here. The multi-beam here, it was collected during a hydrographic survey conducted offshore Makovic, Nunatiavut, during leg 2 of the 2021 expedition. Some scientists use it for, choosing the right spot in the seafloor to collect sediment sampling with a box score, for example. The summary, the CCGS Amundsen is dedicated to support Arctic research. During the last 2 decades, 19 scientific expeditions have been accomplished, even during the pandemic time. The data set from the ship are processed and QA/QC'd following state-of-the-art protocol, and the data that are published is used as open data for to do open science for the scientific community. Many papers have been published, all paper related to the use of the data from the Amundsen. So on that, I would like to thank you for your attention, and I would be happy to answer some questions. Thank you.